things. Can I ask you to click forward one slide in the GoToMeeting? A couple of follow-up things to that too. As we mentioned, we're here in June at session 3. Session 4 will be in a few weeks. Just in case it's not on anybody's calendars, the workshop is August 1st and 2nd. I know that Kim and the project management office have been working on logistics with a number of sites. If things are all set for you, great. If not, we're kind of coming up on the point where things like travel arrangements and hotels and that sort of stuff need to be made. So if you're having any issues with that, please reach out to us and let us know. We are also asking that folks finish assignments before the workshop so everyone can get the most out of the workshop. And again, if folks are running into any difficulties with assignments, then please reach out to us. And in particular, as I said, Hanya is coordinating the whole course, so she has the best view on sort of what things fit into each assignment. We would be happy to help provide some guidance. Okay, with that said, let's take a step forward again, and we're going to focus on a really practical topic today, and that's use of the Atlas application for cohort discovery. So if you're working at an institution that is more involved in the Odyssey consortium, you have probably bumped into this application a time or two before, just because it's one of the tools that's heavily used in setting up network-wide study protocols. We will use it in a slightly more constrained way in PEDSnet, and we want to focus on that today. That said, all the capabilities of the tools are out there, and anybody who wants to do additional analyses with it are certainly welcome to. Let me get you to click forward if you could, one for me. Right, and talk about Atlas broadly. All right, so it is built by the Odyssey Collaborative as a tool that is intended to provide a set of defined self-service capabilities in using data in the common data model without requiring a lot of independent technical skills in SQL or SAS or R or other sort of data management languages. It has 3 main purposes in the consortium. It's a platform for data exploration. We'll talk about that a little. Basically, it's doing the kinds of things that you may be used to doing in Achilles if you've been using the DCC's web tools. It is useful for cohort construction, and in particular, while the entry cost is a bit higher than other tools, it's very flexible in the options it offers for cohort construction. And so this is the area we're going to focus most of our time, and this is the place that we will use it most frequently in PEDSnet. It is also set up to do defined analyses, things like population level effect estimations or patient level predictions or that sort of stuff. Again, feel free to use the tool. This is not a major use in PEDSnet at the moment, and so we're not going to focus on that today. But we may be able to come back to that in the future as folks get more settled into it. In terms of the target audience, one thing that I do want to mention is that this is a tool that's generally focused on people who are familiar with the data model. You don't need programming skills, but you do need to know your way around the data. And so in particular, we're presenting it to this group because these are people who are relatively data friendly. It may be that as other investigators at your sites want to ask feasibility questions, they'll need to do that in conjunction with you. It's sort of, well, you'll see as we go forward. It's a little hard to sort of hand the URL to somebody and say, okay, go to town. All right, some quick technical background just in case folks are thinking about deploying this locally. It's open source software that's created and made available by the Odyssey Collaborative. There are a set of lead developers at a couple of Odyssey partners, but there really is sort of multi-site contribution to the framework. It's hosted on GitHub. That's the place where you post bugs. It's where you get the code from. And as with all open source software I have ever encountered, it is in a state of constant evolution. So there are point releases and they have defined feature sets, but in general, we expect this to have moving capabilities, and we expect it to have moving weaknesses as well. And so part of the way we use it in the network will involve dialogue about what it can and can't do. All right, let's go ahead and dig into it. Atlas, the application, consists of 3 components. There's something called the Web API, which is a Tomcat-based middleware layer that brokers access to the data model for a variety of applications sitting on top of it, including Atlas. This is not something that you'll need to deal with unless you want to deploy Atlas locally at your site and make use of it against local databases. For the databases hosted at the DCC, this is something that we maintain. There's Achilles, which is the name for the set of data exploration or data summarization and sort of straightforward data quality tests that the Odyssey Collaborative distributes and that are incorporated into Atlas. Again, for DCC data, this is something that that runs at the DCC, and the results will be available to you without any additional work. And then the web component itself makes use of Node.js. If you're running it in a web browser, you need to allow that web browser to execute JavaScript, or otherwise not a whole lot is going to work for you in Atlas. You'll actually find yourself stuck at the splash screen. All right, then. That's how it's built. Moving out of the deployment space and into the user space, there are a variety of features that we're going to investigate here. And you can see down the right side of the slide, I have copied the function menu from the home screen of Atlas. Right? We are going to spend most of our time in the top half of this menu today. But you can see that there are a variety of analyses that you can perform as well. There's documentation available for these on GitHub, and I encourage people to explore. The one thing that there isn't a whole lot of room to explore is the option called Profiles, where you see a picture of a single person. Right? So this is the graphical display of a single person's longitudinal history, and we have disabled that in PEDSnet. Again, because we want to limit the risk to privacy of individuals, and because we expect users to be at various PEDSnet members, there is the possibility that someone using Atlas will have external knowledge of a particular patient and could recognize a patient given enough accumulated information about that individual. There's governance discussion going on as to whether it may be useful to re-enable that in certain circumstances, but for now it's disabled. Okay. Cohorts is where we're going to spend most of our time. And in Atlas, a cohort is basically a stack of several steps, right? The root of cohorts from the user's perspective are code sets, or what Atlas calls concept sets. Those code sets are used to create rules that then select patients from the population, right? And so what you do is you come up with a definition of a cohort that is based on these inclusion and exclusion rules. It centers around an index date, which can be fairly flexible for a given patient, and then builds out from there. The cohort construction is fairly flexible, and so I've already mentioned it allows for inclusion and exclusion criteria. It allows for temporal associations between criteria, so you can say things like, got a drug after receiving the diagnosis, or was discharged from an inpatient stay and then had a certain outcome. And you can express the criteria across different domains so that you can include patients based on their collected diagnoses, the procedures that they've undergone, medications that they've received, and so on. Atlas provides you not just with the ability to define the cohort, but with the ability to retrieve counts and to do some descriptive reporting and visualization. It also keeps track of the cohorts that are created so you can come back to them later, or as we'll talk about more in the next session, you can save a cohort in Atlas and then use the standard R code that we have to go back around and extract that cohort from the database in order to perform further computation. Finally, Atlas gives you the capability to import and export cohorts across instances of Atlas, so that it can interoperate not just with the DCC at PEDSnet, but with other members of the Odyssey Collaborative. All right, let me stop there and ask, just does anybody have any questions about the overall structure of Atlas or its broad purpose?
So Charlie, this is Daksha, and I came in about 5 minutes late, so I'm going to apologize if you've already covered this. Atlas is a de-identified aggregate cohort explorer tool. Is that right? Which is the initial feasibility assessment. Am I saying this right?
All of that is true, yes. And I would recommend it for feasibility assessments. You know, there are some other analytic tools built in, but I would think of it in the feasibility space.
Right. It's not something that investigators or even us can download data sets from. When you say we can save, import, export cohorts, what does that mean?
So you can import and export the rules that define a cohort, and you can export descriptive characteristics about the cohort, but you cannot download
the data set.
Individual level data. Yes. Atlas will save the list of patients who are in a cohort, and we have tools in the standard R framework that we use to go back in and retrieve those patients and operate on them. So, you know, there is a path from an Atlas-defined cohort to individual level data sets or analyses, but that's not available through the tool. That's got to come through specific coding, and that's fairly deliberate because we want to make sure that we get to the governance that's required for individual data sets.
And again, in this new realm, and I know we still have some confusion about roles of DCC, roles of analyst at the site, and the investigator. I understand that, but are you envisioning, or you might get to it, are you envisioning Atlas to be the tool that we roll out to our investigators, PEDSnet investigators here once they're interested in a PEDSnet study? Is it going to be limited to just my team who is, you know, on the grant, or how are you envisioning this?
Yeah, we envision Atlas as one of two reporting tools that can be rolled out to a broader audience who want to do data exploration. Now, I will say in our experience, it's hard to hand this to an investigator because it immediately, the entry price is dealing in things like concept sets and inclusion criteria and that sort of stuff. And so it's not quite a drive-up application. And I imagine that probably this is the sort of thing that you could train people at your institution to use, or you could sit with somebody, you know, sit with an investigator and kind of in real time refine a cohort. We're also going to deploy a tool that replaces Harvest that has that kind of low barrier to entry, although it's not quite as capable. And that might be the kind of thing that you would more kind of notify people in general or make publicly available. It will be more limited in capacity, but it will have a lower entry cost.
Correct. Harvest is more about a general view of the PEDSnet population. What fields are available and what does that distribution look like, if you will. Is that right?
Yeah, and some really simple cohorts. You know, you can ask yourself how many people have diagnosis X or that sort of thing. But it doesn't do temporality, it doesn't do exclusions, that sort of thing.
Okay, so I'm so sorry to take this, but my next question then with Atlas is this going to be just limited to people who come through DCC for a PEDSnet specific study? Like, I can see this being helpful to just our investigators here, regardless of whether they're interested in a PEDSnet study or not, because we could look at it across and even our own data. Is that right? Or is this a pool? Can I go into here and select just Seattle data in Atlas?
So right now it's all pools for purposes of anonymity. It is easy enough for us to set this up in a way that would let you select just Seattle data. And again, if we get kind of governance consensus on doing that, then we're fine deploying that.
Perfect. Okay, so then this could be one of the entry points into a PEDSnet study, right? I'm thinking of this from a grants perspective, from making sure it's used appropriately, making sure that PEDSnet gets the how do I say this, the advantage, right, it takes from you getting, or PEDSnet getting more studies, not you, but us.
Yep, I agree. And so we actually see this as operating in two spaces. One is kind of pre-application with an investigator who is far enough along to be saying, hey, I want to lay out my cohort criteria for an application, and I want to generate a sort of ballpark estimate of enrollment so I can write my letter of intent or my grant application. So that's step one. And then step two will be early in the funding cycle for an investigator to sit down with an analyst or a data scientist and say, okay, here's my project, here are my cohort criteria, let's actually build the cohort. You know, this is an alternative to sort of sitting down and filling out the forms in isolation. And you know, gives you more immediate feedback on the impact of some of the choices you make. It's not perfect, but it's a workbench that I think can be pretty effective at that step.
Yep, perfect. Thank you, Charlie. This really helps.
You're welcome. No problem at all. Okay, so let's walk our way through the features we're going to talk about today. I want to start with what Atlas calls data source exploration. For those of you who have used Achilles before, it is going to look extremely familiar. So in Atlas, you can identify a data source. At the moment, there is only one. It's the pooled data. We may, as I said, evolve to a point where there are site-specific data sources as well. And then within that data source, you can ask for information about specific domains. So what you're seeing here is for the pooled data, I've shown you the overview of diagnoses or conditions, which reports out as a tree map. And then I clicked on the most common condition, acute upper respiratory infection, and shown you part of the specific information it will then generate for you, where you get an age-specific and time-specific distribution of the data. There are additional panes that I haven't pulled into the slide that show you where the diagnoses come from, or what kinds of patients, that sort of stuff. So this is your way to ask single questions of the data. Right. The other thing that the data source tab provides you is Odyssey's view of Achilles, right? So Achilles is a set of, I want to say it's about 150 now, kind of straightforward checks about the structure of the data. And you'll get a list of results that Achilles generated. So, you know, I picked a few out of the DCC data where you can tell, unsurprisingly, that it's flagging the fact that we have some unmapped records. So cases where the concept ID is 0, and it's just telling you that it's got a number of those. We also get, routinely notifications that we have procedures occurring before the date of birth, that sort of stuff. Right? So again, I encourage you to explore this. It's fairly self-explanatory, and it gives you a sense of what's in the data. But that's not really what you're going to want to use Atlas for most of the time, right? We're going to want to get to actually. Go ahead,
Charlie. Hey, this is Janet.
Yeah. Sure.
So this is expecting an OMOP data source. Is that correct?
Mm-hmm. True.
So how does Atlas interpret the PEDSnet specific tables, like the ADT occurrence table or the PEDSnet specific fields that are not part of native OMOP? Does it just ignore those?
It does. It skates right past them.
Thank you.
Sure. So the first step into finding patients of interest is finding out how to describe those patients. And that starts with looking at the vocabulary. Now, if you look at the search tab in Atlas, that's an undirected way to see what's going on in the vocabulary. Right? You can start by just typing a word into the search box and searching for it. Here, I've looked for pneumonia, and it will return to you the terms in the vocabulary that describe pneumonia. You can see here that there are 3,600 different ways to say pneumonia in the healthcare universe that OMOP knows about. Right? This gives you an idea of what might go into a code set. In addition, what it does is gives you information about what terms are in actual use. So if you look at the results here, what you'll see on each row is some metadata, right? The internal ID or the concept ID, the the code in the source vocabulary, the name of the source vocabulary, and so on. Of most use to most people, there's the name of the concept. Here, the top one being Streptococcus pneumonia antigen assay. So this is people testing for strep pneumo, right? And then it gives you the RC and the DRC, right? And we'll return to these a little bit later, but briefly, the RC is how often that term is used. The DRC is how often more specific refinements on that term are used. So you can see that nobody here is using the term Streptococcus pneumonia antigen assay, right? But there are lots of people using derivatives of that, specific titers and serotyping and things like that, okay? So you can use this as a way to get a good start on what terms might be useful to you in building up a code set. Right? On the left side of the screen, and I've clipped it out and reproduced it here, there's a set of selection boxes that you can use to narrow your exploration, right? So once you got back 3,600 terms for pneumonia, you want to ask yourself not just which ones are used, but which ones apply to me. You notice the most common one has to do with testing for strep pneumo, which is probably not what you want if you're looking for people who have pneumonia. So you can use those boxes on the left to narrow your search to things that you want, right? In particular, you can pick a domain, and again, you'll want to remember for PEDSnet purposes that the condition domain is actually broader than the way OMOP or Odyssey would interpret that. So that's anything that came out of a visit diagnoses, drugs, observations, measurements, which is where both labs and vitals fall, procedures, and so on. So here I picked condition, and I brought it down from 3,600 to 1,100 terms, right? There are boxes at the bottom that help you figure out what's in use, right? So standard concepts, again, remember back to lecture one, are the concepts that are actually in the database, right? So Atlas doesn't know about source values. It only knows about the standard concepts. So if you're looking to build a code set to find patients in the database, you want to look for standard concepts. You want valid, non-invalid, terms. Standard concepts are by definition valid, so that's a little redundant here. And then you can start asking yourself, do you have any data, right? So in this particular case, I picked records that have direct use, right? And if you think back to the previous slide, I would not have gotten that that Streptococcus pneumonia antigen assay because it has no direct records. It only has descendants. But the most common diagnosis, pneumonia, actually does have records. So these are ways to narrow your search as you explore things. And once you do that, you notice that you can narrow that search down from 3,600 terms to 129 terms, which are describing diagnoses of pneumonia, are arranged in a nice hierarchical way, and have data associated with them. Right? So this is your entry point into recognizing populations and building code sets. It may be as far as you need to go if the only thing your investigator wants to know is who had a diagnosis of pneumonia. Again, if you clicked on that blue pneumonia term, part of what it would tell you is it's the parent of all of the other pneumonia terms. And so its descendant record count are all of the diagnoses of pneumonia of any kind. And for really simple questions, that's all you need. If you wanted a person count, you go to the data source search and look it up there because that's person counts instead of record counts. Okay, so things to remember when you're looking at the results. We talked about record count and descendant record count. In particular, you want to pay attention to the DRC because that's going to tell you where more specific terms are in use. You want to remember that these are record counts, not person counts, right? So there aren't 9 million people exposed to amoxicillin. There are 9 million people who have or 9 million cases where amoxicillin was in a record somewhere. Again, if you want the person count, the quick way to do that is up in data source. Great. Okay, so
hey, Charlie,
we figured out how to...
Sorry, Charlie, sure, in the previous slide,
yep.
What's RC and DRC again?
Sure, so RC is the record count, and that's the number of records in the database that use this term exactly. So there are 3.3 million cases where what the prescription record said is just amoxicillin was in the bottle. It has no further information. The DRC is descendant records. Remember from the first session that a descendant record is a more specific form. Okay. right? So, by contrast, nobody has said there's amoxicillin oral suspension in the bottle, right? When you can get to that level, you can probably get to a more specific value like concentration, and so everything is in the descendant records.
Right, so that's why most of the previous ones for record counts, you have a 0 because that's a descendant, not a primary. Got it.
You got it, exactly. So amoxicillin oral suspension has nothing, but amoxicillin 80 mg per mil oral suspension had about 2 million records, right? Because then that's the level the pharmacy was operating at.
Yep.
Great. So we've talked about how to find terms. How do you collect them? Because if you want to know who has pneumonia or who is exposed to amoxicillin, you can see from those prior screens there is no one term that's going to give you the answer to your question, right? So the way Atlas approaches this is with what they call concept sets. This is their term for code sets, right? The reason that the name is useful to remember is that fundamentally what's going on here is that this is a list of concept IDs. So when you build these sets, you're going to be hitting the standardized concept columns in the tables. You can create them from searching the vocabulary. You can take a list of codes that you want to import, and it will look them all up and give you a starting list. You can import a structured code set from another Atlas user. You can export your code sets to Atlas. However you get there, this is the way that Atlas is going to touch the data. So it reaches into the database only through concept sets, and that's how it identifies records of interest. As a logistical matter, you can see that there's a top-level pane here called concept sets. Those are global concept sets that you can use in any cohort. If you build one of those, just as a courtesy, prefix it with your initials because you're sharing that space with everybody else. We will build at the DCC a subset of concepts that are for global use, and those won't have initials. But if you're if you expect to do 4 studies and using the same code set, I want to put it in the global space, it's fine. Just prefix it. Within a cohort, you can also define cohort-specific concept sets that are only visible within that cohort. Since it's only visible in that cohort, don't worry about collisions with other cohorts. Okay, so let's talk about how to get to concepts. You go to the concept set screen, you click on concept set in that sidebar, right? And that will start a global concept set. You just click new concept set. Or in a cohort definition, you click the concept sets tab. And again, you can go ahead and click new concept set. Typically, you're going to use search to find the terms of interest. One of the columns in results you may have seen go by that I didn't spend a lot of time on is over at the left, to the left of all of the codes, there's a little icon of a shopping cart. When you're building a concept set, the way you say, I want this term in my concept set, is you click on that little shopping cart. If you want everything on the screen, click on the shopping cart at the top of the list, they'll all get added. If you want some and not others, click one at a time. And then you go back to the concept set definition to decide how the term gets used, okay? Admittedly, that's a little bit clunky, but that's kind of how the system works. So you can see it in operation here. You start in the concept set screen, you create a concept set, you give it a name, right? And then to start adding concepts, you click on the search button on the left, if you can click again for me, and that brings up the vocabulary search, and you can see those little shopping cart icons here, right? So hypothetically, if I want patients who have bacterial pneumonia, then what I'm going to do here is select the terms that might be bacterial and not select the term that is viral. Go ahead and click again. Once you have the concept sets together, you have to decide back in this concept set expression tab how you're going to use them. So by default, when you select a concept, it's an inclusion criterion, right? So it's pulled into the concept set. You have a couple choices you can make now. Those 3 columns over on the right give you the options. So descendants means include this concept, but also include all of its descendants. You are typically going to want to use this, right? And you're typically going to want to do that so that you get more specific variations on a theme rather than just the name in front of you. Sometimes that is all you want, but think hard if you're not checking descendants. The column to the left of it is also often useful. It's exclude, and what it says is invert the sense of this concept. So pull in all of the terms, but then use them as exclusions. If those terms are present, ignore the record. So again, you'll see me here taking another step down the path of trying to define a bacterial pneumonia code set. So I took the terms that I had selected previously, right? I didn't select the generic pneumonia or lobar pneumonia terms because I thought they were kind of nonspecific. And I did pick viral pneumonia and pulled it in, but then designated it and all of its descendants as an exclusion criterion. So they'll be thrown out of the concept set. You can see how this is working as you go, because right next to the concept set expression tab, there's something that's going to say included concepts, right? And there's a number there, and as you select and deselect things, that number changes. So you can see that this set of criteria has pulled in 111 different ways to diagnose bacterial pneumonia. For your information, there's the next tab, included source concepts. And if you clicked on that, that would give you a list of all of the things, standard, not standard, from whatever vocabulary, that eventually would lead you into the code set if the ETL mapped them correctly. Again, you typically don't want non-standard concepts in your code set because they're not typically what you're going to find in the standardized columns in the table. But if you want to see, hey, did my ICD-10 code of interest actually make it in here? You can look for included source concepts, and that will tell you any source record that started with that ICD-10 code and was mapped correctly would or would not land in this code set. Right? And then export and comparison lets you compare code sets to each other and see where they differ. Alrighty.
So I have a question on the previous slide, if you can go back.
Sure. Shoot.
So what if, so right now you, for viral pneumonia, you said exclude all descendants, right?
Right.
What if you just didn't check either of those boxes? Would that still be included because you've selected pneumonia as your top?
Well, I selected viral pneumonia, and you can see that because the little shopping cart is gold. So if I didn't check any other boxes, then that specific term, but only that term, not any of its descendants, would be included.
Oh, I see.
Right. So this code concept set would find a patient who had a diagnosis of viral pneumonia, but it would not find a patient that had a diagnosis of viral pneumonia due to influenza.
Right, as its descendants. So it would include that. But by doing these two, you're excluding viral pneumonia and the descendants. You
got it. Exactly.
So then, and I know you mentioned this, so I can still see a shopping cart in front of pneumonia and lobar pneumonia.
Mm-hmm. So those are
by not checking either of these boxes, are we pulling those in? Are we excluding them? Or they would just...
We're pulling in exactly those terms, but not their descendants.
Yep.
Right.
Okay, suddenly, yeah, it made sense. Thank you.
You bet. And it's just a really pragmatic decision I made in this particular code set that those terms were used often enough directly that the investigator would probably want to see them.
Yep.
Okay. And you can get feedback on that if we go to the next slide as you build the code set, right? If you move over to that included concepts tab, you'll get the concepts that are in. Everything here is in the code set. This is maybe a little confusing in the display. Those orange or golden shopping carts mean that that is a direct member of the code set. The gray ones mean it's a descendant, but they're all in the code set. And you can look right there and see your friends RC and DRC, so you know what terms you're pulling in and how often they're used. You'll want to do this routinely, right? You'll build your code set and then you want to explore what codes are in there, because sometimes the descendants have kind of head-scratching relationships and you say, no, I need to throw this one out. Or sometimes, you will find that you are missing a code and need to go back and look for it. And this is the place that you can assess that. So tips when you're making concept sets. Just to reiterate, the database contains standard terms. So if you're looking for terms in the database, pick standard ones. I know everybody here knows that. I say that as many times as I do because, to your point, Dr., when you talk about rolling this out to people, an investigator may be really confused if they come up to this with an ICD-10 code set and build a concept set out of those, and then it finds nothing. Right? And that's because what you're looking for are the standard terms that were mapped from that. There are lots of ways to say things in these terminologies, so you probably want to start with a more general term and include descendants rather than try to individually find every term that might match. And you will almost always have to exclude some subtree because there was a descendant that wasn't what you wanted. Okay, enough said about concepts. So concepts are one of the building blocks that go into cohorts. And again, cohort, not surprisingly, is the name that Atlas gives to a group of persons who meet a set of criteria. Those criteria are ways in which concept sets relate to each other, right? We'll go through the details in a bit, but briefly, you can have individual inclusion criteria that can be based on either and or logic, right? You can say any of the following diagnoses or all of the following procedures, right? And then as each criterion is applied, that is necessarily a subset relationship. So it's necessarily and logic. In other words, what Atlas is doing here is attrition-based cohort construction. Okay, so keep that in mind when you decide what is one inclusion criterion and what should be broken out across many. All right, so let's walk through what it takes to get to a cohort. I'm going to start again with just general etiquette. All of the cohorts are global. There's no kind of site-specific cohort namespace yet. And so when you build a cohort, please prefix it with your initials. Please don't edit other people's cohorts. Be careful. It's easy to change things clicking around. Those changes don't persist until you click on the save icon, but be careful not to unintentionally change somebody else's cohort. They may have a study who depends on it, or that depends on it. But feel free to borrow stuff. So I mentioned there are study-specific concept sets. If another study has a concept set that you need, feel free to go into that cohort, export the concept set, and import it into your own cohort. If it's a concept set that we're seeing repeated frequently, we may even just bump it up to the global space. Okay, nuts and bolts. So cohorts start in Atlas with what's called an initial event. So remember when I said before that Atlas cohorts are based around an index date? So the cohort process always starts by looking for something. That something needs to be clinical, right? So you can't say start with everybody or start with everybody under 10. You have to say start with somebody who has something going on. That's why I say it needs to be clinical facts. And often what you will say is, I want somebody who has this clinical experience and has a certain amount of time follow-up or something like that. That's fine. The goal here is to get yourself a reasonable starting point. On the one hand, you don't want to try to specify your entire cohort in your initial event criterion. It will become incredibly complex, and you won't be able to see much information about attrition, because from Atlas's perspective, this is only one step. On the other hand, the bigger your starting cohort, the longer cohort processing takes. So you want to find a reasonable starting point. What I've put up here is an example from a prior pre-application feasibility question we got, where somebody was looking at patients who were diagnosed with anxiety. So what we said here was that the initial event would be recording of an anxiety diagnosis, and hiding behind that green label is a concept set for diagnoses of anxiety. It had to occur in a time frame that the investigator could use, and it had to be in an age group that the investigator could use. So that established the first step into cohort entry for these patients. Okay. In addition to that initial event, you can have what are called initial event inclusion criteria. So other things that you want to say are necessary to just kind of get across the low bar to be in the start of my screening group. This can be additional clinical criteria. This is where you can start asking about subpopulations. So this is a little bit redundant in some cases, but here what I said is what I really want is to look at a cohort of girls, because this is an investigator who wants to study dysfunctional uterine bleeding, right? So what I said here was your entry can be any diagnosis, because I just want to know that you saw somebody and got a diagnosis, right? But as an additional inclusion criterion, I need to know that you're female, and so you are theoretically at risk for a diagnosis of dysfunctional uterine bleeding to get a reasonable estimate, okay? Again, don't overspecify here. This is not how you build your cohort. This is just how you get your initial screen. And this lets you narrow things down a little bit. All right, go ahead. Once you've gotten your initial cohort, then you start getting to your group of interest by adding what are called additional inclusion criteria, or in analyses, additional qualifying inclusion criteria. And these are the attrition rules that whittle down your entry or your screened cohort to the group that you really want to get to. This is where within a criterion, you can say A or B or C, or A and B and C, right? But each criterion stacks on each other. So you want each criterion to accomplish one step on the way to a cohort. We'll show some examples that go into further detail here. If you look at how this fits in, right, you start your cohort and you define it, right, and then you supply the initial event criteria, right? Here, what we're asking for is a CF diagnosis with a couple years or a year and a half of follow-up. Go ahead. Right, and then you specify these additional qualifying criteria, and you can see this study has 3 criteria. An additional CF diagnosis. We wanted it to happen over time to confirm the diagnosis. We want the patient not to be on a particular drug, right? And it says drug exclusions here. You may want to actually name it, but if you look at the definition over on the right, the drug you want to exclude is ivacaftor, right? And again, what you want to say is that this patient can never have been on the drug. You could also say all days before and no days after, was not on the drug at baseline, right? Or no days before and all days after, wasn't on the drug after baseline. Also note that the way you exclude here is you say with at most 0 occurrences, right? Because these are all framed as selection criteria for your cohort. So if you want to kick people out, then you say at most no. So some quick best practices then for defining these criteria. Start with the largest practical screening cohort because you're not going to see attrition. So what you're seeing at the bottom is a tree map of the attrition step by step. Right? If you throw everything into your initial event cohort, it's all going to be one big box, and that doesn't help you. Keep the criteria specific thereafter so that you can follow how many people get lost at each decision. Again, try not to lump together. Be careful about the relative timing. Know what you want in your baseline period. Know what you want after the index date. And then finally, the ordering, you saw 1, 2, 3 in Atlas is arbitrary. It's how you define them. So go ahead and order them by the attrition pattern that you want, because why go through the work of generating an attrition list manually when Atlas will do it for you? Okay, I did mention before that there are cohort-specific concept sets, and we're just showing you here that there's a tab within the cohort definition that allows you to define these concept sets. They behave just like any other concept set, and so we won't go through the process of defining them again. Once you have the criteria for a cohort defined, you save that, and then you move 2 tabs over to the Generate tab, and that's what actually gets you the process of looking for patients. You have 2 options there, Generate or Generate with Features. So if you click Generate, that's just going to get you a count of patients. And what we recommend is that's the first step you want. I know that all of us think about describing the cohort and looking for features. The issue is you can generate a cohort typically in about 10 minutes. Generating with features gets you up into 45 minutes or so, because it's doing a lot of descriptives. So keep on generating and looking at the attrition pattern until you think you're somewhere close. How long it takes depends on complexity. So if your initial event cohort was 5 million people, get a cup of coffee. If your initial event cohort was 2,000 people, you probably have the results in 5 minutes. Once you think you're in the ballpark, then you can generate with features to better examine the cohort. And again, this is a little bit of Atlas East. Generate with features means describe the cohort for me at day 0, right? So things that were going on prior to the start of a study. And it takes a bit longer to generate. What you get, though, back from that is attrition, right? This comes with just a generate, right? Where you can see step by step how the cohort behaves, where people were filtered out. You can either display it as a tree map, or if you look down at the bottom, you can display it as a classic attrition diagram. And that will also tell you who remains where. Okay. Once you generate with features, you get all of these additional characteristics of the cohort, again, at baseline, not once you've passed the index date. There are lots of severity indices in there as well. Sadly, the ones that are in the box at the moment are all adult-oriented. Hopefully, we will be able to as we have resources available, start baking some pediatrics into this. But you will, in general, find that Atlas has a bit of an adult view of the world, right? It only thinks of ages as happening in years. It provides adult comorbidity indices and so on, right? And when you get these features back, you can look at what's going on. So in this particular cohort, you can ask yourself, what's the age distribution of patients? What's the ethnic distribution of patients? That sort of stuff. And as you click across those other options, you'll get information about what are common conditions and so on. Right? Here, for instance, we're looking at diagnoses. You got to hope that most patients in a CF cohort have a diagnosis of CF, and that's actually the case. There are some variations on it, right? And you can see what comorbidities are common. In particular, not everybody has the diagnosis CF because not everybody got that specific term, but you can click on Explore and see how the descendants distribute and so on. So this is a great way to assess whether you've got the right people in your cohort. Once you're in the right place, then you want to move to exporting and importing. So we talked about row level data beforehand. That's kind of beyond the scope of today. Atlas allows you to export your cohorts for analytic use in two ways. You can spit out a structured JSON document that you can then import into another Atlas instance or reuse later on in Atlas. You can also generate SQL against a variety of relational data database backends that will select the cohort for you in another OMOP instance, right? So if you plan to hand your cohort off to another Atlas user, use the JSON generation. If you plan to hand it off to someone who's got an OMOP database but is not deployed Atlas, use the SQL generation. Okay. In addition, go ahead and click through here. You can, quote, export reports that may be useful for your investigator, right? So these are summaries of what gets you into the cohort that they can review and file away as part of their analysis plan. Okay, I know that was a sort of rapid tour of what's going on. What we want to do is actually spend some time walking through how cohorts are built, because we think it'll be more useful to try to anchor this in actual practice. And I'm going to start that process by handing off to Dan Eckrich from Nemours. The group at Nemours has been exploring the use of Atlas and have kindly agreed to help us out in the training series by sharing some of their experience. So I'm going to hand off to Dan, and he's going to walk through some work that they've done at Nemours, and then time permitting, we'll walk through a second example that reflects some work that we've done here at the DCC. All right, thanks. Take it, Dan.
Hey, Charlie, this is Tim.
Any chance that Dan is talking against mute?
I don't know. He might have been expecting me to steer the boat on this.
Okay, please feel free.
Can you hand the... Oh, his mic is not working, I see. Okay, so I'm trying to figure out how to share my screen here. Ah, there we go. Are you seeing the Atlas screen now?
Yes, now we are.
Okay. So at Nemours, we actually have a somewhat older version, I believe, of Atlas and our installation. is a little bit different in that it's also running against our internal uh, uh, common data model rather than the data coordinating centers model. So there are some slight differences, but hopefully the general interface and things will look the same. Um, we pulled together just a couple of really quick examples to show here. And I'm going to start by bringing up the concept sets that we've defined. And I'll start with some concepts that are related to sickle cell disease in children, um, so that you can see what we did with that. I find it useful often to expand the screen so that I can see all of the um, concept sets at the same time and find the ones I'm looking for. So here are three, in fact, that are related: acute chest syndrome, vaso-occlusive crisis, and the general uh, diagnosis of sickle cell disease. So for acute um, chest syndrome, we have um, a superordinate classification, and I've just clicked into it. You'll notice that it's now doing some calculations of related concepts and the concept hierarchy related to that. So we can see now in this display that the acute chest syndrome has a record count of 3,800 patients and a descendant record count of 39, which means that there are not a lot of descendant records from that in the system. And in fact, they all accrue to the acute chest syndrome due to sickle cell C disease. Also notice that in our instance, we're not seeing the nice necessarily the nice record count and descendant record counts that that Charlie was able to show from his examples. But nonetheless, there are records there, and um, the superordinate record categories. The only thing of potential interest would be the SNOMED code for disorder of lung, which is way too general, so we don't want to start there and have to eliminate a large number of things. So sticking with the acute chest, then we can go back to the cohort or to the concept set definition. One of the things that we've found is a constant gotcha with the Atlas interface to keep in mind is that if you make any change to the interface, for instance, if I did decide to include descendants of chest pain here, which I don't want to do, then we would end up with the highlight up here indicating that we need to save our work if the change that I just made is going to take effect. Now, I don't want to save those descendants here, but it would again be too general and pick up too many things that are unrelated to the cohort of interest. So that's the definition that we're using for acute chest syndrome here. Then going back to I can close this concept set and open another concept set. In this case, again, spread this out to find the right things. Find vaso-occlusive crisis is another one. And here there was just one concept that we found that seems to be the primary concept in the way our internal data set was coded. And finally, I can close this and we can look at the definition of sickle cell patients overall. And there are these categories that we've found for the way sickle cell patients are coded in our system. We also want to be careful to eliminate patients who show up as sickle cell trait rather than sickle cell disease. And there are some records apparently of mothers who themselves have sickle cell disease and that was complicating childbirth. We don't want that diagnosis or descendants of that diagnosis in our cohort or in our concepts for this. So then using those concepts, we can go into the cohort definition system and going to look at the cohort that I also already defined. We'll start with the vaso-occlusive cohort. So this is now a cohort of children who have experienced a vaso-occlusive crisis. We're going to look at the patients from 1 year before the time of that diagnosis up to the time of the diagnosis, and we're going to look at the latest diagnosis of that in our data set. The other thing that I wanted to do is include all sickle cell patients, whether they had a vaso-occlusive diagnosis or not. And so that would be this second criterion here. Having chosen the criteria, then you can go up, and we don't need to save this because it was already saved, but I would then go into the generation stage and run the generation, which, because this is a very small set, I can do. Notice that in our instance, we don't have the option of generating features. We can only do the broad generation, and we see that there are 328 patients captured by that. We called our internal data set OMOP, and we can select some information from that comes up as a standard report. So for instance, we can look at the class of patients who are captured by that query and see that that they are primarily African American, which should be no surprise. And we've also, I'll close this data set then, we've also created a cohort of patients with acute chest syndrome. Now, the way sickle cell disease works, of course, many patients have both acute chest and vaso-occlusive crises over time, sometimes even in the same event in the hospital, the same hospitalization. They may cycle from one of those to the other. But right now, we're just pulling out two separate cohorts from the overall sickle cell population who are identified by having that specific event in the 365 days before that. And one of the reasons for pulling both of those two cohorts out separately is that we can then go into the categorizations grouping here, which I did not see in the examples that Charlie and Hanya were illustrating. And look at a comparison of the ACS patients and the VOC patients with sickle cell disease. In the characterization set, we can then design the characterization by importing a set of cohort definitions. In this case, I've imported those two code sets that we just looked at. We can import or look at importing some features related to those code sets. And those are selected from a very large list. There's 104 in all. I've selected just a few features that we wanted to look at from related to those patients. Let's see if I can figure out how to close this. There we go. And these are not features that require analysis parameters. That would be in the case that there was something, a feature, for instance, that was had an age parameter that needed to be specified for the feature or something like that. We can then look at executions. I can generate I can make changes to the design. And I've made several changes to the design over time. Every time you make a change, then you need to generate a new execution of that comparison. And we'll just look at the latest results from the various different runs that we were working with earlier today. I find it helpful in this display to um, sort by the standard difference. I'm not sure whether the standard difference here is what the units are. I suspect it's standard deviations, but the differences appear larger than I would expect for that. Charlie, do you happen to know what that um, what that what the units are for the standard difference?
No, I'm sorry, I don't.
So in any case, we can see now that we have the two different cohorts, those who were identified with acute chest and those who are identified via vaso-occlusive disorder, and we can look at ways that those two cohorts differ from one another, and that's also illustrated here in some graphics. All of the orange illustrations here are related to differences in drug exposure, and the blue ones are related to differences in procedure occurrences. So one of the large differences that we see here for the acute chest, there were many of these intravenous infusion for therapy or prophylaxis type procedures. 42% of the ACS patients and just 15% of the VOC patients were seen for that event. And there are similarly some others that go in the other direction. This is another bug in the local version of the system now. I'll never be able to get rid of this picture in the middle of my screen, no matter what I do. But in any case, that gives us an illustration of the differences between the two cohorts, and we can then explore that and follow up on interesting differences there. This is just the procedure data now illustrated separately. And again, if I sort by the differences, we can let float to the top the things that distinguish the two cohorts. Here's a DNA test, basically looking to genotype the patients. That seems to have been run more frequently in the ACS patients than in the vaso-occlusive group, and vice versa. We have a lot more occurrences of the intravenous infusion here for hydration in the VOC group. I imagine that this is because they were hospitalized, whereas the acute chest patients were probably spending less time in the hospital. And there's also information on drug exposure that we requested, and again, sorting by differences there. Fairly large difference in subscriptions of zithromycin. That would be related to the possibility of the acute chest patients developing pneumonia. And some of these went in the other direction as well. Let's see. Well, the differences in the other direction are not as large here. I was thinking I might see some differences due to infusions or prescriptions of hydroxyurea, but I'm not spotting them at the top of the chart here. Anyway, that's the sort of, and finally, just a raw breakdown of the visit counts for the two patient sets. There were a few more ACS patients than VOC patients, and fairly large visit count for both of them. So that's one general exploration of a definition of a code set and exploration. Maybe this is a good time to stop and ask if you have any questions about that before we take a quick look at one other thing. Hearing none, I'll move on to, this is a little bit another tricky thing related to the Atlas interface. This little breadcrumb up at the top here tells me that I'm still looking at the ACS cohort. And so I want to drop back and close that cohort out so that I'm not linked to it at all. And now I can choose a new cohort to look at from this group here. And I'm going to look at a cohort of patients with otitis media. We were attempting to locate a group of patients who had otitis media but did not have an eardrum rupture, so that we could compare that group to a group of patients who did have an eardrum rupture to see what sorts of differences in the way those patients presented prior to the eardrum rupture. Our code set for the concept set for otitis media with no rupture. I'm in the cohort, but let me drop back to the concept set for a minute. And here too, we have several cases of things where we're looking at to include along with their descendants, and code sets to exclude along with their descendants. We want to exclude from this code set because it's supposed to be patients with no rupture. We want to be sure that we are not bringing in any patient concepts that include eardrum rupture or their descendants. And here's two different diagnoses that might capture that we want to exclude from this code set. Going back to the cohort. As Charlie indicated, one of the ways that, in addition to defining code sets that have no rupture among the codes that we're extracting, we also need to look for trying to eliminate any patients who have had a rupture, regardless of whether we identified them via the code sets. And to do that, we define this exclusion criteria basically by including, whoops, sorry, I clicked on the wrong thing. By including at most 0 occurrences of eardrum rupture in the cohorts who have no rupture that we're trying to define. So we can then go into the generation for this, and I won't run it, but you can see that it locates about 17,000 patients in the Nemours data set. And we can again look here at the kinds of patients who have been extracted from that. And we see that it begins to roll off pretty quickly as we get to the end of the line here, partly because of that 1 year look back that's required for patients, so that we can't really have people who've been in the system less than a year. And then we can also look at patients who have had, I'll close this cohort and move on to a different cohort, which would be a cohort of patients who have had an eardrum rupture. And in this cohort, we want to pick patients whose eardrum rupture was the first event in that patient's history. And again, a look back of 365 days from the event of the eardrum rupture. And selected the earliest event here, consistent with it being the first one in the patient's history. This locates 4,111 patients in our data set. And a much larger possible set of reports that we could look at from that. To be honest, I'm not sure why we're seeing a larger set of options here than we were in the other case. It's another Atlas mystery that we're still trying to figure out. And this is a slightly different set of patients, as you can see from the different profile here. Closing this, finally, we can look at a characterization that involves those two cohorts of otitis media patients, and we want to look at the cohort that had an eardrum rupture and the cohort that is not supposed to have an eardrum rupture, and see what are the differences in those. And a few features that we've pulled out here are condition era, start long term, the demographics of the patient set, their age, and any procedures prior to the event date. And when we look at the executions for this, again, I won't actually run the execution, but we can look at the most recent one. And start to look at the differences here. And we can see that chronic otitis media is common for both our cohorts with and without eardrum rupture. It's much less common in the eardrum rupture. I believe that's because the way we defined the cohort was that we wanted this to be the very first time that the patient was seen with an eardrum rupture, and that may be the first time that the patients had a history with us as well. So there's a small number of patients there, whereas the overall cohort of kids with otitis media is pretty huge. To see if I could find here. One of the things that I was hoping to be able to show you here in this grouping is the fact that despite the way we defined the cohort, there were, remember, 4,111 patients who did have a rupture. We are still in some cases seeing an eardrum rupture in patients who were supposed to be in the otitis media without rupture cohort. And in fact, in this column here, where it looks like all 4,111 of them have showed up in the otitis media without rupture column. So that's another Atlas mystery for us. I think that's a good place for me to stop. Hopefully, Charlie has some examples to show you that actually worked correctly, as opposed to ones that don't. But I think this is instructive in the sense that it does illustrate that that they're getting the interface set up and configured correctly is one challenge, and also being able to define the cohorts in a way that extracts the patients that you think you're extracting can be quite challenging. And in this example, doesn't appear to have sorted the children out quite the way we expected it to, in that all of the otitis media patients with eardrum rupture were somehow included in our without rupture cohort, despite our best efforts. And Charlie, at that point, I can turn the presentation over to you unless there's questions that people have about this.
Okay. Do folks have anything that they wanted to ask about the things that Tim was walking through? Okay, then thanks very much for that, Tim. I think that was actually a great walkthrough of the way the interface works and some of the things that you can do with it to assess your cohorts as you build them. I will second Tim's observation that Atlas is very literal-minded, and it does exactly what you ask it to do, and it may not do what you intended it to do. And so it's hard to over-recommend the value of stopping at every step and checking which concepts are in your concept sets, which patients are in your cohorts, because you may find that there is some magical way to say, I want everybody who has a diagnosis of otitis without a rupture, and then you would need to, as a separate criterion, say something like, and at most 0 occurrences ever of otitis media with rupture. Or you'll get somebody who might have had a historical rupture, right? Or if you only care in the last year, that figuring out what goes into it, what you get out of leaving something out of a code set or out of a rule, and what you get out of selecting against it can be really finicky. Some of the age comparisons can be a little tricky too. If folks have time, I'm happy to walk through some additional cohorts. I know some folks may have to leave right at 3:30, and that's fine as well. Please drop off if you need to. If you can stay around and find it helpful, then we'll go over by a few minutes, hopefully not too many. And for everybody, this will be available on the recording. Right, so I am going to steal the screen, if I could, for a minute. Hopefully, if I've done this correctly, folks can see my Atlas cohorts window. All right, so what we're looking at here are a set of cohort definitions, and I'm going to try to do a couple of things that just kind of walk through ways you could think about approaching a cohort. So I mentioned in the initial description looking for dysfunctional uterine bleeding for a patient. And what you see here is a pretty simple cohort definition, where what we've said is to be included, we would like to find a diagnosis of DUB. I could have said a diagnosis of any condition. That would have given me an initial cohort of about 3 million patients, which is viable, but takes quite a while. So we imposed this as an entry criterion, right? We did ask for female gender concept ID here. So for female sex in the cohort, that's a little bit redundant with the diagnosis, but gives you an idea of how you can further constrain the initial event. And then within this set of patients, we asked for people who had undergone testing for von Willebrand disease and not subsequently in time, but had also received a diagnosis. If you look at, we've pre-generated the cohort. If you look at the behavior of the cohort, what you can see is that, of the patients, there's a large group of patients who have been diagnosed with DUB, and then of them, only about 5% have a diagnosis of von Willebrand disease, and only about 10% have been tested. So that you can look here to see how they overlap, right? You have the attrition view that lets you look at how things fall off at each step, and here you can see who is missing which of the criteria by. You can watch as I move my mouse over the boxes, various of these criteria highlight in red. So right, these are patients who have DUB and have been tested but have never gotten a VW diagnosis. These are patients, excuse me, who have passed only one criterion. These are patients who have passed none of the criterion, and so on. Okay. So this is a way to get some information before the characterization step. You were right, Tim, by the way, the characterization option isn't rolled out here yet. That's something we're hoping for in the next couple of months. It is tangled up in the current version with some of the machinery necessary to get to site or people-specific workspaces for cohorts, and that machinery is buggy. So we're working on getting that fixed with the folks at Odyssey, and once that's fixed, we can think about deploying that. So look at some other definitions quickly. I mentioned the value of an entry criterion. So here's a cohort of patients we wanted to find who had type 2 diabetes. And one of the things that we were aware of from some of the computable phenotypes work is that it's fairly common that someone will get one recorded diagnosis of type 2 diabetes and then not have that confirmed or have their course evolve in a way that indicates that's not what they have. So what we said was, in this case, we're going to start with a diagnosis of type 2 diabetes. And again, there's a code set behind that. Right? You can actually, if I walk back here and mouse in just the right place, see how you can select different code sets. And as you mouse over the code sets, it will show you what's in them if you don't want to have to switch to the concept set tab. But then we also said that we wanted a year's run-in for these patients, and we wanted to make sure that somewhere in there was a second diagnosis of type 2 diabetes, so that we would not select the patients who had a single occurrence, right? And at most 0 occurrences of type 1 diabetes. So we wanted to select against the patients who in their baseline period, so all days before and no days after the type 2 diagnosis, had a type 1 diagnosis. So we didn't want to catch miscodes, right? And you can use that as a sort of quick cohort definition in and of itself. And you can set that off and run it. And I'm going to go ahead and run that, and it's going to work for a while, but we'll come back to it. You can also tell once you've set something off that something is happening, because if you look up here, this little notification icon will turn gold if there's information you haven't looked at yet, right? And here you can see that this job has started but is not yet complete, right? Once you've looked at it, it goes back to white. While we're waiting for that to finish generating, I want to show you how that plays out in a more complex cohort. So when you're actually considering running the clinical trial, then you can start with a similar cohort. We actually allowed a little bit of leak through of type 1 coding in here in this particular cohort because miscodes happen in both directions. But then you follow that with the rest of the inclusion and exclusion criteria. And you can see here that there are about 20 additional criteria that are used to include and exclude patients. So this is a situation that much more closely resembles what you would need to do if you were trying to find patients eligible for a clinical trial or find a cohort of sufficient uniformity that you could do certain types of observational analysis. Right? And this is a more complicated process, so we pre-generated these. Right? When you do that, you get the more complex attrition diagram that I showed you before. And again, you can use the mouse here to try to find cells and figure out what criteria groups patients are falling out on. Right? The attrition view tells you where you have big single criterion drops, but the intersect view then tells you, like here's a substantial group of patients. What actually cost you those patients? They were one criterion failure, and that was the type 1 diagnosis. But these are patients who failed 2 criteria. What might they have been, right? And so on and so forth. Right? We also generated features for this cohort. So again, you can see what was done baseline in the baseline period. What are the things that are relevant for this cohort? And it takes a little bit of patience to load the reports against the large database. But if you look at groups of drugs, you can see that the most common group of drugs are anti-diabetics or drugs used in metabolism, right? And that's exactly what we would expect. If we look for a single term, metformin is the most common term. The most common drug group or chemical grouping is the group that contains metformin. This is giving you some feedback about the utilization patterns that you would expect in a patient population that was selected for diabetes. If you dig down into things, again, with sort of pauses for cohorts to load, you will get more information about the members of that class. Now, a couple of things have been going on in the background. You notice that this icon's turned gold again, right? So that's telling me off on the side that that cohort generation has moved from started to running. So, okay, useful information, we move on. We've also generated reports for this cohort. I won't go through the details of this because I think Tim already walked through some of the reports, but I will just as a reminder say that among the options you get here, if I can get this to pop up. I'm sorry, the pop-up is not showing up very well on GoToMeeting, so I'll have to leave this to your exploration, are both the kinds of reports that you would expect during from Achilles, but additional reports that have to do with the behavior of the cohort. So for instance, this is called a completeness report for the cohort, and you will find that in these age bands, there is almost complete capture of sex and reasonable reported capture of ethnicity, meaning the usual qualifications as to how correct that is, and so on, right? So this gives you an idea of data completeness across demographics, right? There are information about what patients happen at, or what care sites are happening, so you can get an idea of how broadly distributed the patients are, and what they call an entropy report, so where the cohort spreads out in time, and so on. I think it is probably most useful to encourage folks to explore this for a few cohorts than to try to walk through it. I will point out at the generation step, you have the option of generating only partial feature sets, right? And if you click on the question mark, you'll get a sense of what feature sets give you what and how long you expect them to take, right? So again, once you've generated a cohort, you can get more information about this. This differs from what you see here in that these are features at baseline, right? And these are features in the cohort. The last thing I want to just highlight with this cohort is you can see that there are lots of inclusion and exclusion criteria because we want each one to do exactly one thing, right? And the reason that we do that is not because it changes the number of patients that we have at the end of the day, but for two reasons, actually. The first is that in the generation step, we get useful information about attrition as opposed to, we went from an initial large group of patients who had one diagnosis and then bam, lost half of the cohort, right? And the other thing that it does is when we export the cohort, it gives you a clear report for the investigator of how you got there, right? And in particular, it lets you line up how the various criteria relate to each other. Okay, I think in light of the time, I'm going to forego any other exploration of these examples. I am happy to walk through things with folks. If as you start to explore Atlas, you bump into things that don't seem to make sense, it's not too hard to get there. As I said, it's a very capable tool, but it does ask for some familiarity with the tool. So we will try to give you a chance to acquire some of that familiarity in the exercises that follow this session, but please don't hesitate to reach out. What questions does anybody have today? Okay, well, then I want to thank everyone for their time. We really appreciate it, and I hope you have a good afternoon. Thanks again, Tim, for taking the time, and thanks again, Hanya, for organizing and for helping people get through all of the session 1 and session 2 concepts.
Sure.
Thank you.
Charlie, when do you think you'll have the Atlas instance at the DCC up and available to the students?
It's up now, so if you're one of the current registered users, it's available to you now. If you're new and we're not one of your site's registered users, then it will be available as soon as we get through the process of getting you a set of credentials at CHOP.
Okay, thanks.
You bet.